So the first type of cryptographic technique we're going to talk about is the familiar one. It's also called symmetric cryptography to signify the fact that the same key is used on both sides. Okay, so you use the key on the plain text, and that produces ciphertext, and then to decrypt you again use the same key, and then you get a plain text output back, right? And then if you think of the encryption as a function, then the decryption simply is the inverse of the original function. Okay, so from a cryptanalysis perspective, in terms of what the attacker sees and what the attacker needs to do, we can understand it using this picture. So there's the message source, and then the encryption algorithm, and then the encrypted text gets sent on the wire. On the receiving side, the decryption algorithm is applied on this ciphertext, and then the plain text is retrieved back. From the attacker's perspective, the attacker has access to the channel, and so the attacker can look at the ciphertext and maybe some other information like what we discussed before, and then be able to either figure out what the plain text was, or maybe do even better and identify what the key that's being used. Okay, and from the from the view of the sender and receiver of the message, it gives this logical view that there is a secure channel on which they are transmitting this data, and secure in the sense that the attacker cannot really access or figure out what's going on this channel, right? And that's being, so that is a logical effect of encrypting the data. So we talk about two types of ciphers or secret key crypto algorithms. One is called a block cipher, and another is called a stream cipher, right? So a block cipher operates on blocks at a time. Okay, so the data blocks are typically either 64 bits or 128 bits. In fact, pretty much any modern technique will work on a 128-bit block size, whereas a stream cipher is used to operate smaller quantities of data, or something, or you may have a long message which is produced 1 byte or 1 bit at a time, and then you want to encrypt and send this small amount of data as soon as it's available, right? So for that purpose, you would use a stream cipher. Okay. Now, why do you have to use a different stream cipher? Why can't you take these block cipher algorithms and simply apply it to doing stream ciphers? Rather, what I'm asking is, why can't you just take, why can't you encrypt? What is the advantage encrypting one big block at a time as opposed to, say, one character at a time? And this relates to what is called a statistical attack on cryptography, right? So the point is that, can an attacker, simply looking at the encrypted message, figure out what the original text is by simply performing some kind of statistical analysis, right? So imagine for a moment what's happening is that the attacker, imagine for a moment that we are applying an encryption algorithm that takes one character at a time and is basically encrypting that one character, okay? So now the property of this algorithm is that the same input character will always result in the same output character. So, so the problem then is that now, even though the attacker